Welcome back, everyone. Today we are going to talk about angles inside and outside of triangles. First, we'll start with the triangle angle sum theorem. This states that the sum of all the measures of the angles in a triangle must be 180 degrees. For example, with this triangle ABC, the measure of angle A plus the measure of angle B plus the measure of angle C must equal 180. I'll show you how to use this in this example below. It says find the measure of each numbered angle in the figure shown. Well, I see two triangles, triangle ABC and triangle CED. In triangle CED, there are two unknowns, angle 1 and angle 2. So let's start with triangle ABC. I'm only missing the measure of angle 3. So I know that I could write the measure of angle 3 plus 78 plus 20 must equal 180. Just so I know for later when I come back to look at my notes, I'm going to write that this is the triangle angle sum theorem on triangle ABC. It didn't ask us to justify, but I just want to make sure that I'll know what I'm doing later on when I come back to look at my notes. Now to solve this equation, I'll first start by combining like terms on the left side of the equation, and then subtract 98 on both sides to get 82 for the measure of angle 3. Next, I still need to find the measure of angle 1 and 2. I noticed that the measure of angle 2 is a vertical angle with angle BCA. They're formed by two intersecting lines. So that means that the measure of angle 2 must also be 78 degrees. I'll make a note next to that saying that this is based on vertical angles with angle BCA. Now I can use triangle angle sum theorem on triangle CDE. I know that all the angles in triangle CDE must add up to 180. Combine the like terms. And subtract 139 on both sides. You should get that measure of angle 1 equals 41. Please pause the video and try the two practice problems below. Here are the answers for part A. There are other ways to do this problem. This is just one way, but no matter how you try to solve it, you should get the same answers. Similar for part B, there are many methods to solving, but no matter which method you choose, you should get all the same answers for your angle measures. Alright, so based on triangle angle sum theorem, we have a couple of things that must be true. So corollary basically just means like this follows directly from this theorem. So these two facts, the first one states that the acute angles of a right triangle are complementary. Here's a proof, very quickly. It's not going to give any reasons or anything, but I'll just explain it to you. So for example, in this triangle ABC, I know that all the angles add up to 180. That's triangle angle sum theorem right there. I know, however, that the measure of angle C is 90. So I could substitute in 90 for the measure of angle C. By subtracting 90 on both sides, I end up with the measure of angle A plus the measure of angle B must be equal to 90. This will always be true for a right triangle. The two acute angles will always be complementary. Also, there can only be, at most, one right angle or one obtuse angle in a triangle. For example, if you had two right angles in a triangle, you would have 90 plus 90 for two of your angles. One angle would be 90, another angle would be 90. The third angle, let's say it's x. You cannot have this equal 180 unless x was equal to 0. However, it's not possible for the third angle to have a measure of 0, so it's not possible to have two right angles in a triangle. The same would happen if you had numbers greater than 90. You would get a sum greater than 180, which is not possible. Alright, next we are going to talk about the exterior angles in a triangle. So first you need to know what an exterior angle is. An exterior angle is an angle such as angle 1 on this triangle. It's on the outside of the triangle. It's formed by extending one of the sides of the triangle. This time we extended side CB to form angle 1. The two remote interior angles for angle 1 are angle B and angle A. Remote interior angles, this is another vocab word that you should know. It means the angles that are inside the triangle that do not share the vertex with angle 1. Now we can talk about exterior angle theorem, now that you know what that vocabulary means. It can be abbreviated EAT. Here's what it says. The measure of an exterior angle of a triangle is equal to the sum of the two remote interior angles. For example, in this case, the measure of angle A plus the measure of angle B must equal the measure of angle 1. Let's do a practice problem together. So it says, find the measure of angle JKL in the triangle pose shown. So with this girl doing yoga, I see that angle KLM, this angle here, and angle LMK, this angle here, are the interior remote angles for angle JKL. Therefore, I know that the two remote interior angles must have a sum of whatever the measure of angle JKL is. So I'll take x plus 50, and I know that that should add up to 2x minus 15. Now this looks like an equation from algebra that I know how to solve. I'll start by subtracting x on both sides. Next, add 15 on both sides, and you'll get x is 65. However, they didn't ask us for x, they asked for the measure of angle JKL. So we have to substitute x back into the measure of angle JKL. So the expression for JKL was 2x minus 15. So instead of x, I'm going to substitute in 65. Now I can simplify this, and you should get the measure of angle JKL is 115. Pause the video and try the practice problem below. Here's the correct answer. 40 and 90 are the interior angles that are remote for angle 1. So if you add them, they should have a sum that adds up to the measure of angle 1. Let's try one more problem together. So looking at this, I want to find the measure of angle 1, 2, 3, and 4. Right off the bat, I notice that for angle 1, I have this right triangle, triangle TZY, and I know I just learned that the acute angles in a right triangle must be complementary. So I know the measure of angle 1 plus 52 has to equal 90. Because those are the acute angles in triangle TZY. So I know the measure of angle 1 must be 38. Again, I'm just writing this down, the reason, just so that when I go back, I know where this equation came from. Alright, so I have the measure of angle 1 is 38. Now, I can do something similar for the measure of angle 2. when I look at triangle XYW, I see that it's a right triangle with angle X as the right angle. So that means the acute angles must be complementary. Therefore, the measure of angle 2 must be 52. I got that by subtracting 38 on both sides. Next, I see that angle 2 and angle 3 together make a right angle. They're complementary. So I know the measure of angle 3 plus 52, since I know that's the measure of angle 2, must be equal to 90. Therefore, the measure of angle 3 must be 38. Finally, I need the measure of angle 4. I see that in triangle WTZ, I only know one of the angles. However, I see that angle 4 and angle 3 are the remote interior angles for angle TZY, a right angle. Therefore, these two remote interior angles, angle 4 and angle 3, which I know is 38, must add up to the exterior angle, the right angle, which has a measure of 90. Therefore, the measure of angle 4 must be 52. Finally, I'd like you to explain why a triangle cannot contain all types of angles, acute, right, and obtuse. Why could it not have one of each angle in the triangle? That's all. Thank you.